Hey everybody, and welcome back to the channel. In this video we're going to be taking a look at this old PC that I bought for 30 euros. That's right. Anxious to see what's inside and what it does. And for the moment it doesn't do a whole lot. Nothing on the screen, no beeping, nothing. So let's take a look at what we have here. I just love this mechanism here to open up this desktop case. Really convenient. Inside we have a fairly traditional layout. We have a couple of expansion cards, power supplies, some drives. Looks like a pretty small motherboard. Let's see what kind of expansion cards that we had. So this is a VGA card which I've been testing with just to make it a little bit easier. Now the PC came with another video card. It wasn't VGA, but it was this card here, which is an 8-bit ISA Magic combo card. I'm guessing this is either going to be, MDA, Hercules, or CGA. It does have a color option, so I'm guessing CGA. Now I did test the monitor and the video card that came with this computer in another computer, so I've been using my Grape XT class machine for that. Now initially I thought I didn't get any video output, but apparently it was just the brightness or the contrast that was set incorrectly. So after fiddling around with these buttons, all of a sudden I saw something appearing on the screen, which was good news. It did need some fine-tuning because, as you can see, that MS-DOS prompt here appears to be mirrored. There are a couple of knobs on the back of the monitor that allow you to change the horizontal and the vertical settings. So after fiddling with these buttons there on the back, I was able to get the monitor in a state where it was able to display everything without any issue. So I was pretty confident that both that Magic Combo video card and a monitor should work. Moving along, we have another 8-bit ISA card here. So let's see what we have there. So this appears to be some kind of I/O card. We have two serial ports, and on the card itself we have a parallel port and a mouse port. And the final expansion card is a 16-bit ISA card, which is the ID controller for the hard drive and the floppy drive. I did notice that that ribbon cable here for the hard drive was put in the wrong way. So normally there is a marking for pin 1. Which was okay for the floppy drive, but not for the hard drive. So yeah, I need to look into that. And here we get a better view of the motherboard. We have the battery here, which is starting to leak. We have a couple of dip switches. And we've also got some connectors here that we're going to be removing now before we get the motherboard out of the case. Now the motherboard wasn't screwed in really tight. There were two screws which were holding the motherboard in place, but I have the impression that it needed a couple of additional ones. As I was pulling out the motherboard, I noticed that there were still some cables attached. I couldn't get to these power cables here because they were underneath the power supply. We also have some connectors here for the turbo button, turbo LED, and the reset button. I'm also going to be removing the power supply out of the case so that I can test it also. And disconnect all of the drives here, the two floppy drives, this one here being a 5 1/4 one. I'm guessing 1.2 megabyte, but could also be 360 kilobyte. Here we have the power supply. We also have a 3.5-inch disk drive, 1.44 megabyte, and the hard drive, which is a Seagate ST157A, a 40 megabyte hard drive. So yeah, now that I've got everything on the bench here, let's see what it does. So as expected, I'm not getting anything out of it. No PC speaker beeps, no video output, nothing. So I'm testing this with the original monitor and the Magic Combo video card because I know that that one works. A couple of things we can test. I noticed that the CPU was warming up, so it was definitely doing something, but obviously not enough to display any kind of output. We can also use one of these postcards that should give some additional information on how the computer is doing, but can also work against you because sometimes these post boards can cause a computer not to boot. So yeah, kind of mixed feelings about that. But I didn't get anything out of it. There weren't any numbers shown on the display here. It did react to the reset button, but yeah, nothing useful at this point. We can also test the voltages. I'm using the ISA bus here because it has pins for all of the main power rails. So the 5 volts, the -5 volts. We also have the -12 volt here, the 12 volt. So yeah, everything is located on that ISA bus, and it gives you the option to test it kind of end to end, because normally these power rails go through that battery section, and if that got corroded, then you wouldn't see those voltages here on the ISA slots. I did got some beeps out of the system as I was playing around with the dip switches, but that could just mean that the dip switches are in a faulty position. So yeah, not really sure what that's about. I did remove that barrel battery because it did start to leak, so it's best to just remove that altogether and then see what kind of damage it has already caused. At first glance, it didn't appear to be much damage, but you never know once you take a closer look. But before we do that, let me walk you through the other parts of the motherboard. Here we have the AMD 286 CPU running at 12 megahertz. So this is a 286 AT platform. We have room for a floating point unit, which is not populated for this 286. We have the standard AT style power connector and the standard 5-pin DIN connector for the keyboard. We have a G2 chipset, which was a pretty popular chipset for 286 based systems. I think this was purchased by Headland at some point. Here we have the keyboard controller. So here we have the section where I removed the battery. You can see some corrosion here leading up to the oscillator. We'll look into more detail on that. There are 4 dip switches here. I didn't find any documentation on this motherboard, so I have no idea what they do at this point. Here we have the memory, so it's not using your standard 30-pin SIM modules, but it's using these dip packages here. This one has 1 megabyte of memory on board, but it also has the option to add 30-pin SIM modules or SIP modules, because these aren't the traditional SIM modules where you have a connector. It's a pretty small form factor board, so we only get 4 16-bit ISA slots and 1 8-bit ISA slot. Here we have the 2 BIOS chips. This is a Phoenix BIOS. So 2 32 kilobyte EPROM chips on the motherboard here containing the BIOS. I'm just going to be removing the memory chips here so that you can get a closer look on how the actual modules are laid out. And as you can see, these kind of dip packages, which contains the memory now, is kind of positioned between the 4 SIM or SIP connectors. So I guess you can opt to either go for these SIP modules or dip packages, or even combine the two. So you get these 30-pin connectors here. They are marked, so you have pin 1 and pin 30. And the idea is that you just populate those with these SIP modules like so. So they're kind of like SIM modules, only they have these kind of headers attached to them so that they can slide into these SIP connectors here. Now, as you can see, the BIOS chip is very close to the actual connector, so not all of your SIP modules will fit on this board, and that's, you know, related to the small form factor of this motherboard. Everything is kind of crammed together. Here we have the battery section with the corrosion leading up to the oscillator. So yeah, you can clearly see that there is some damage here from this via here. If you follow the trace underneath the oscillator here, there is definitely some damage, and it's difficult to see if, you know, this trace here is broken or not. And on top of that, you don't really know where this trace is leading to. Here I made kind of the assumption that it was going to go to one of the pins on the oscillator here, because it was kind of aligning up to that point. And we all know that assumptions are the mother of all mistakes. So yeah, even here in this case, I kind of went along with it and actually went so far as to just assume that this would go to this pin here. And I actually already created a connection using a wire just to verify everything. But then I thought, you know, it might be better to just double check, get the oscillator out and see where the trace is actually leading to. And it's a good thing that I did, because beneath that oscillator there was a lot of battery damage there. So I took it off completely and then kind of scrubbed it with some vinegar here to kind of neutralize the damage from the battery. And then cleaned everything using isopropyl alcohol so that we get a good view on what we have underneath here. So let's take a closer look. And wouldn't you know it, as you can see, the trace here doesn't go to that pin, but it goes all the way up onto this via over there. So yeah. And the thing with these vias is that it's very difficult to even get a continuity reading from them, because you really need to approach them with your, with your probing tips at a certain angle. Otherwise, they just don't make any continuity. So here I'm already made the assumption, again wrongly, that the trace was broken, but as you will see in a bit, this wasn't the case. So here I'm just using my tips at a slightly different angle. I didn't do anything, and as you can see, the continuity is definitely there. So yeah, next up, it was time to take a look at the actual crystal. So I got the pin out here where you can see that pin 1 is not connected. On the same side, we have the ground pin. Opposite to that, we have the output pin. And on the other side, we have the VCC. So let's check this one here. This one is not connected, so we're not interested in that. This one is the ground pin, so this should give continuity with here on the AT power connector. Here we have the output of the oscillator, which goes into this resistor here. So when the thing is running, we can check to see if we get a signal out of that. And here we have VCC that we can also verify using the AT connector. So yeah, I think these 4 pins are okay. Now you got to make sure that you clear all of the solder from these through holes here before you put the thing back in. So definitely double check. So yeah, time to put the oscillator back in. Make sure that it's oriented correctly. So there is a marking there for pin 1. It's always a good idea to take pictures of the before situation just to make sure that you put everything back in the way that it should. Now, if you have a multimeter with a frequency setting, you can measure the output of that oscillator. And as you can see here, we have it clocked at 25 megahertz. So that seems to be okay. But I did notice that there was one trace that was broken, and that's between the 2 vias here, which should provide continuity. And the issue with this is that, you know, the via is broken somewhere, somewhere between these 2 points. And they're very difficult to get to because the via here, for example, is connected to this G2 chip here, which is very difficult to solder, you know, a botch wire to. And also for the other pin, I wasn't able to find a through hole pin that I could easily attach a cable to. So, you know, at that point, basically the only thing that you can do is try to solder onto these vias directly, which is, you know, a pretty difficult process. It's something that you definitely should avoid, but sometimes you just can't avoid it, like in this case. So what I did was I just added a little bit of flux, and what I tried to do was to just put some solder onto that via so that hopefully we can attach a botch wire to it. So yeah, I'm definitely not an expert at this. I tried just filling the via here with some solder, but turned out to be not the easiest thing. I couldn't get the solder to attach itself to the via, and that's probably because there is some kind of coating or solder mask on top of that via. So at that point, I decided to kind of scrape off very gently some of that solder mask, and you can clearly see that, you know, the via becomes a lot more shiny, and then hopefully it should be better to attach some solder to it. Now always make sure to clean everything properly with isopropyl alcohol just to get rid of the contaminants. And you know, as you can see here, it's pretty shiny. So hopefully we should be able to drop a little ball of solder into that and then hook up a wire. So let's see how it goes. So yeah, just gonna add some flux here on top of the via, and then hopefully we should be able to get some solder in there. So yeah, I'm hoping that's going to be sufficient. So let's clean everything up. There are some burn marks here, but that's part of my, lousy soldering skills. But the via seems to be filled with sufficient solder to hook up a wire. So yeah, let's hope for the best. I did the same thing on the other side. So there's a blob of solder there as well. So let's see if we can attach a wire now and get that continuity back. So again, same procedure, adding some flux to the solder filled vias here, and then just attach a small wire onto it, just to make sure that it sits properly, and then a quick continuity test just to see that everything is okay. Now we focused a lot on the top cover of the PCB, but we also need to look at the back of the PCB, obviously, where we had the battery sitting. So here is the area where we had both the battery and the oscillator. So I'm just going to be cleaning everything so that we get a nice view on the status. And what we can already see is that there might be a couple of traces here that have some issues. So let's take a closer look. For example, here, I see a couple of black spots here. I see a trace which is potentially broken here. So let me zoom in a little bit. You can see here the via here. It's not 100% sure if it's still properly connected. And here we have some damage to the traces. And sure enough, if I do a continuity test from the via over on the left side here, let's just follow the trace here all the way up to the right, and it goes around here. We should have continuity, so let's check. And we don't. So there's definitely an issue with that trace. And just to have a clear view on where the issue is, I'm going to use my fiberglass pen. I'm just going to gently scrape off some of the solder mask and just get that copper exposed just to see where the breakup is. So yeah, just rubbing the top of the PCB here, and as you can see here, the copper becomes visible. And you can already see that the trace is cut somewhere in the middle. But to get an actual view, we first need to clean this up a little bit. And, it's not just a matter of, blowing this off of the PCB. You really need to clean it because there's definitely going to be still some residue left. So again, you use isopropyl alcohol to clean everything, to get rid of all the contaminants. And what we end up with here are 3 traces with the copper exposed, giving us the opportunity to see where the issue is. And I can already see on the bottom trace here where you see that black spot that the trace has been cut. So yeah, this definitely gives us a much better view than what we had before. If we do a continuity check now, we can see up until this point we have continuity, but after the breakup, which is on the right hand side here, we lost the connectivity. So in order to fix this, what I'm going to do is I'm going to take this little piece of wire and I can bend it into a similar shape as the trace has. I mean, the fact that the trace goes into a bit of an angle here makes the repair a little bit more difficult because it's just at that corner point where the hiccup is. So I'm just going to be soldering a piece of wire like this over the trace, and hopefully that should fix it. Okay, so time to add some flux here using my flux pen, and then see if we can get that piece of wire soldered onto it. So I'm just going to be tinning that copper trace on both sides a little bit just to get some solder on there, which will allow the piece of wire that's going to go on top of that to bite. Should have done a little bit more on the right, but hopefully it should be enough. So I'm just going to pick the wire here, place it on top, and then just see if I can attach it this way. Because we've also exposed the trace just above this one. We need to make sure that we don't short anything. So that should be it. Just gonna get rid of that little tip here on the left. And then just a quick continuity check before I cut off the remaining piece of wire. Continuity check is good. So this trace should be fixed. So yeah, just gonna be cutting off the remaining part of that little wire here, and then we should be good to go. And lo and behold, the machine does start. So that's already good. We do get an invalid configuration and we need to run the setup program. Obviously the CMOS settings are invalid. We can change the disk drives, the hard drives, base memory, extended memory, display, keyboard, and CPU speed. Now there is 1 megabyte of RAM installed on this machine. The count is okay, but for some reason I cannot change the memory settings here in the CMOS. It's kind of stuck with a base memory of 1 megabyte and extended memory 4 megabytes. I can't change the memory settings for some reason, so it will continue giving this error for some reason. So might need to look into that. What's also strange is that the time isn't progressing, so it's kind of stuck at 1 minute after midnight. And when we start the machine, we also get this error message saying that the clock chip or the time of day clock has stopped. So not that it's not set, but it has stopped. And, you know, not really sure what that is, if it's just because there is no battery installed at the moment. And the fact that I cannot change the base memory or the extended memory is also a bit worrisome, so also need to look into that. But perhaps what's even more surprising than the fact that I was able to fix this computer is that we have a working Seagate ST157A IDE hard drive in here. I've seen a lot of these passing by and a few of them actually worked. So yeah, I'm pretty happy that this one boots straight off the bat. Just need to configure it as hard drive type 46 in this particular CMOS setup. And as you can see and hear, the hard drive is good to go and boots straight into MS-DOS. So yeah, I have to say I really like the look and feel of these old 3.5-inch IDE hard drive, Seagate ST157A. I mean, just look at this thing. Amazing that it still works. Like I said, I mean, I've seen a lot of these passing by my desk and more broken so than anything else. But yeah, pretty happy with the fact that this one with the cover and the LED is fully operational. We also have a 5.25-inch floppy drive here. Not really sure what kind of model this is. I'm guessing it's a 1.2 megabyte. I'll need to check that out. But yeah, for now, I'm just pretty happy that we were able to get this PC up and running again. Haven't had any issues with it except for the memory mismatch in the CMOS setup. Other than that, everything seems to work fine. Hard drive is working, floppy drive is working, keyboard, mouse, monitor. So yeah, pretty neat little system. It also came with a printer, so I might need to check that out as well. But that will be done in a future video, where I will be looking at the software that was installed on this machine. No games, unfortunately, but there were some applications installed here, so it will be nice to see if we can find out for what this computer was used back in the day. The fact that it has this CGA monitor does allow it to do some light graphical work like you see here. So yeah, I think it's going to be a little fun machine to play around with. So yeah, pretty happy that it worked out well. And that concludes this part of the video. If you liked it, please consider giving it a thumbs up. Leave a comment in the comment section below. If you haven't subscribed to the channel and you would like to support the channel, please hit that subscribe button and the notification bell. We're gonna cover lots of other retro stuff on the channel. So I hope to see you guys then. Bye-bye.